For this activity, we're going to program an Arduino to automatically water a plant. In addition to the components in the previous activity, you'll also need the following. The Arduino will be programmed to turn an electric water pump on and off based on temperature, the amount of light, and whether or not the moisture sensor is wet. An electric water pump works by spinning a blade called an impeller. The spinning impeller causes water to be sucked in through the inlet of the pump and to be discharged at the outlet of the pump. Links to more detailed explanations of how a pump works are in your class booklet. The water pump that'll be used in this class is very easy to use. All you have to do to make it work is to power it. Make sure you submerge the water pump completely in water before you apply power to it. It's not designed to work without being submerged. And remember, Chromebooks don't mix with water, so make sure your Chromebook is in a safe location in case the water container you're using for this activity spills some water. Before automating the water pump, let's power it up and make sure it works first. First, fill your water container with enough water so that when you put the pump inside, it'll be fully submerged. Next, attach the tubing to the outlet of the pump. Now take the pump and put it in the water container. The pump has a suction cup in the bottom, so if possible, attach the suction cup to the base of the water container. Then aim the tube so that if the pump turns on, the water will flow back into the container. The pump has a red and black wire. The wires are stranded and weaker than the jumper wires that you've been inserting into the breadboard. Twist them to make them stronger and easier to insert into the holes. Connect the red wire to E25. Then connect the black wire to E30. Take the 9-volt battery adapter and insert the red wire into A25 and the black wire into A30. Take the 9-volt battery and position it as if you're about to connect it to the battery adapter, but don't connect it. Just make them touch. Once you do this, the pump should turn on. For the first activity, we provided power to an LED using the voltage source on the Arduino. However, the Arduino can't provide enough power to make the pump work, so we have to use a relay module. A relay module lets us power the pump with a battery but control it using an Arduino. It's essentially a mechanical switch that we can control using an Arduino. There's no schematic symbol for the relay board, but the connections are relatively simple. On the right side, the DC- and DC+ terminals connect to the ground and the 5-volt connection of the Arduino. The input connection goes to an Arduino digital pin. For this activity, we'll use Arduino digital pin 7. The common connection on the left side goes to the positive terminal of the 9-volt battery. NO stands for normally open, and that connection goes to the red wire of the pump. NC stands for normally closed, and that terminal is not used for this activity. Do you remember how we turn an LED on and off using an Arduino digital output pin? Well, this relay module works as if we were physically pressing a button every time you tell the Arduino to send a high signal to the Arduino digital pin 7. Because this module is so specialized, we're not able to draw the physical connections. So for this activity, we'll rely on the connection table in your class booklet and this video to show how to connect the final circuit together. So let's build the circuit. When connecting wires to the relay board, use the provided screwdriver to tighten the connection. Connect the red wire of the 9-volt battery adapter into the common terminal of the relay module. Connect the red wire of the pump to the normally open terminal of the relay module. Connect the black wire of the pump to A30. Connect the black wire of the 9-volt battery adapter into E30. Connect one leg of a long jumper wire to the input terminal of the relay module and the other leg to Arduino digital pin 7. Connect one leg of another long jumper wire into the DC- terminal of the relay module and the other leg into the negative bus. And finally, connect one leg of a long jumper wire into the DC plus terminal of the relay module and the other leg into the positive bus. Before we upload the code to the Arduino, let's go over it. We're going to reuse the code that we generated from the last activity. Not only that, we're going to use a lot of the same code that we used in the blinking LED activity as well. In line 12, we're going to tell the Arduino that we want to control pin 7. In line 27, we use what's called an if statement. If any of the statements inside the parentheses is true, the Arduino performs everything immediately under the if statement. That is lines 28 through 30. Essentially, it'll send digital pin 7 a high command. If none of the conditions in the if statement is true, it performs everything in the else command. That is lines 31 through 34. That means it'll send a low command to pin 7. Now let's take a look at that if statement a little closer. Remember how the temperature, light, and moisture variables store information on what the transducers are currently measuring? And also, remember how you wrote down two values for each of those variables in the last activity? For example, you wrote down what the light value was when the photoresistor was not covered, and what the value was when the photoresistor was covered. You also wrote down what the moisture level was when the moisture sensor was just sitting there, and what the value was when it was placed in water. Because you're doing this activity on your own, your temperature, light, and moisture measurements will not be the same as everyone else's. So you're going to have to change the values in the if statement. When I performed the activity, the analog read measurement when the photoresistor was not covered was 738, and the measurement when it was covered was 916. I need to pick a value somewhere in between those two values, so I used 800. The value for when the moisture sensor was dry was 663. When it was submerged in water, the measurement was 307. A value somewhere in between is 400. Typically, the room temperature is around 25 degrees Celsius, so a threshold of 30 degrees Celsius is recommended. When you put all those numbers in, the if statement will be carried out if either the temperature is greater than 300 degrees Celsius, the light measurement is greater than 800, or if the moisture measurement is greater than 40. That means if we put our finger on the thermistor and heat it up to greater than 30 degrees Celsius, the pump will activate. If we cover the photoresistor with our finger, the light measurement will increase to greater than 800 and the pump will also activate. And finally, if the moisture sensor is removed from the water, the moisture measurement will increase to greater than 400 and will also activate the pump. Now create a new sketch called water_plant and type the code as shown in your activity booklet. Click on Verify and Save. Click on Upload and Save. Click on Monitor, and you should see the same data that the Arduino was sending to the Chromebook in the previous activity. If you haven't already done so, put your moisture sensor in the water, and don't connect your 9-volt battery just yet. Put your finger on the thermistor to heat it up, and you should eventually see a red light on your relay module turn on, and you should hear a click. That means that the relay engaged and is working correctly. Next, cover the photoresistor and see if it does the same thing. And finally, pull the moisture sensor out of the water and see if it does the same thing as well. Now, connect the 9-volt battery to the battery adapter. Cover the thermistor to heat it up, and the pump should turn on. Cover the photoresistor, and the pump should also turn on. And finally, pull the moisture sensor out of the water and verify that the pump turns on. Now, put your plant next to the water container and aim the tube into the plant. Pull the moisture sensor out of the water and observe the Arduino watering your plant. Make sure you put the moisture sensor back into the water, or else it'll keep pumping the water into your plant. Now, try building the circuit, programming the Arduino, and verifying that it waters your plant.